Okay, so we just got done talking about conditional probability, and now what we need to focus on is independence. Independence is kind of a big deal. This is something that you really need to know and really need to either be able to show two things are independent or the opposite. If you know they're independent, then you can do certain things. So, here's the definition of independent. Two events are independent if knowing that one occurs does not change the probability that the other occurs. So, here's an example. When rolling a pair of dice, event A is rolling a 5 on the first die, and event B is rolling a 3 on the second die. Okay, so rolling a 5 on the first, rolling a 3 on the second. Those are independent because just because I roll a 5 on the first die, that does not change the probability that I'm going to roll a 3 on the second. What is the probability of rolling a 5? Well, I could get a 1, 2, 3, 4, 5, or 6. The probability of rolling a 5 is 1 out of 6. Okay, now the probability of rolling a 3, maybe I'll make it a different color. The second dice, the probability of rolling a 3, the probability of rolling a 3 is also 1 out of 6. So they're independent. Each roll is independent. And I think that's intuitive. What I roll on the red dice has no effect on what I roll on the blue dice. It does not change the probability. Okay? Now, let's just do another little example here. If we're going to toss a fair coin twice, what are the different possible outcomes? Tossing a fair coin twice. We could get heads, heads. We could get heads, tails. We could get tails, heads, or tails, tails. So that's our sample space. Those are all of our possible outcomes. So let's say that event A is that our first toss is a head. Okay? So the probability that your first toss is a head. Okay, here's one where the first toss is a head, and here's one where the first toss is a head. That's 2 out of the 4 possibilities, which reduces down to 1/2. Okay, what's the probability that the second toss is a head? Okay, so let's look at the ones where the second toss is a head. Here's where the second toss is a head, and here's where the second toss is a head. That happens 2 out of the 4 times, which is 1/2. Those events are independent. Getting ahead on the first toss does not affect the probability of getting ahead on the second toss. So events A and B are independent. Okay, now let's say we're going to do conditional probability. So this would be saying the probability of B given A. So if I put that in the words, that would be the probability of the second toss is ahead, given that the first toss is ahead. Okay, so this is given that we definitely got a first toss that was ahead. Well, how many options is that, given that the first toss is ahead? It could be heads, heads, or it could be heads, tails. Those are the only 2 where the first toss is ahead. So given that, what's the probability that the second toss is ahead? 1 out of the 2. Okay, all right, now we got some rules. These are the stuff that's in the box is going to be very important, so make sure that you have this written down. These things are true if we know that they are independent. And then also on the flip side, if we want to check to see if two things are independent, then we check these things that will go in the box. It works both ways, forwards and backwards. Okay, so the first rule says if two events A and B are independent, or two events A and B are independent if and only if, this is that if and only if you remember from geometry, the probability of A given B equals the probability of A. The probability of B given A equals the probability of B. That whole idea, here's a way to explain it. Okay, so if we're going to do the probability of A given B, if the events are independent, then B does not matter at all. It doesn't matter what we got originally. So that's why we only need to focus on the probability of A. Over here, probability of B given A. Well, if they're independent, A does not affect the probability of B happening. So this equals the probability of B. What we're given does not affect what probability we're currently trying to find because they're independent. Okay, then another important rule is this and, which we haven't done as much of. The probability of A and B. If they're independent, it will be the probability of A times the probability of B. Now, the or probabilities, when we were doing A or B, that's where we would add, and if there's any overlap, we would subtract the overlap. And you multiply. But again, that's only if they are independent. Okay, so you use these rules when you know they're independent. You can apply these rules, or vice versa. If you're trying to verify that two things are independent, try these out, and if they really do equal, then they're independent. Okay, so here's an example. Here's all our probabilities. Are A and B independent? Okay, well, from the last slide, if they're independent, then what should happen? Then the probability of A and B should equal the probability of A times the probability of B. So let's check and see if that's right. Well, they say the probability of A and B is 0.15, and they tell us that the probability of A is 0.4, and the probability of B is 0.5. Now, is that a true statement? No. 0.15 does not equal 0.20. So these are not independent. Because they do not follow the rule that they should. Okay, let's try this one. Here's all of our probabilities. Are G and H independent? Okay, so we ask ourselves, does the probability of G and H really equal the probability of G times the probability of H? Okay, well, the probability of G and H is 0.18. Does that equal the probability of G, which is 0.3, times the probability of H, which is 0.6? Is that true? Yes, it is true, so therefore they are independent. Okay? All right. This will be, I think, our last question. Yep, our last question. In an apartment complex, 30% of the residents watch NBC for their nightly news. Okay, so the probability of NBC is 0.30. It's a B. And 80% have a computer and can check the news on the internet. Okay, so the probability of watching the news on the internet or just getting their news off the internet is 0.80. If the percent who watch NBC and the percent who have a computer to check the news are independent, what is the probability that a randomly selected person watches NBC or checks news on the internet? Okay, so the big thing is they're telling us they are independent, and now we're going to do an OR problem. Okay, so now go back. The probability of NBC or internet will equal the probability of NBC plus, because it's an OR problem, plus the probability of internet minus any overlap. So do you think there's any overlap of people who watch NBC for the nightly news and check news on the internet and have a computer to check news on the internet? Okay, so if there's overlap, we need to subtract it off. So this would be NBC and internet. Okay, so the probability of watching NBC, they told us, is 0.30. The probability of having a computer to use the internet is 0.80. And now we need to subtract off the overlap. Okay, what is the overlap? Well, let's do a little bit of side work. We are told they're independent. So if they're independent, then the probability of NBC and the internet should equal the probability of NBC times the probability of internet. So the probability of NBC is 0.30 times internet, which is 0.80, and we get 0.24. That's the overlap. So now we can finish the question. Probability of NBC or the internet is 0.30 plus 0.80 minus the overlap, 0.24, and we get 0.86. Or you could say 86%. So the whole key in that problem was they told us they were independent. So because they're independent, we could do all of this red stuff. Okay, and then when we go to do an OR problem, it's the individual ones added up, but then you subtract the overlap. And again, the overlap is when you multiply them. So this one problem ties together like 3 different concepts. So you're pretty much guaranteed to see something like this on a test. Okay, that's it for today. And then on Monday, we're going to keep continuing with 5.3. So you can start your homework now. See you Monday.